And yes, behind me is another Fender Bassman amp. This is the third one this month. This guy spotted my video of putting in that master volume control, so he wants that, and he wants me to go through it, check the caps, because he believes that all the coupling caps on the preamp board are original, which they are. He has already replaced the filter caps, and he put in good quality F&T type, which is great, so I don't have to fool that. But first, let's give the amp an inspection, and then I'll hook it up to the scope and we'll do my noise floor test and see if we can spot any sensitive components. Alright, we'll give her a quick inspection. Top side filter caps have been changed. You can see these cool little dampeners on the tubes. I really don't know if those do any good, but whatever. Original transformers, that's cool. And then the output tubes, you can see that these have been changed with the smaller type 6L6 GCs. So these retainers, the old alligator teeth, do nothing. Anyway, let's go bottom side and take a look. Now here we are bottom side. Now I'm going to take a little more time to look over things because it's critical, right? We want to do it right. So here are the 9-pin tube sockets. And those all look original. And the solder connections look really good on them, right? Now over here are my output tubes, the 6L6s. First thing I spotted is this 470 ohm resistoroid. It's only a half watt resistor. That's a no-no for screen circuits, right? It's not enough wattage. And there's a bubbly spot right in the middle of the resistor. So he's been working pretty hard to support that 6L6. This one over here is the right wattage, but it's extremely dark. So I think he's been baking too. So we're going to change both of those out. Right there you can see this AC socket, which has been changed. That's not original. This is a 3-prong type, and the AC cord was spliced in, and you can see the ground down there doesn't look the greatest, so we'll have to take a look at that. Back to the eyelet board, you can see the cathode caps, the electrolytics have been changed. Still has the old blue crusties. Somebody popped that guy in. That's not original. This is what you normally see, are the old flippity-flop ceramic caps, right? These are bad news, especially for noise, and I bet you we'll see some sensitivity over here. There's another one right there. Of course, all the blue guys are leaving, especially these two, because that's the grid coupling caps going to the output tubes. So if these guys are leaking, it's going to eat your tubes, right? So routinely, I just change them. So of course my main offenders are these two guys right here. These are the grid coupling caps going to your output tubes, alright? So if these guys start leaking, they'll change the negative bias on your output tubes. They'll go nuts and they'll go up in flames. So change these caps. We're going to change all these caps. And no, I'm not going to check them because they need to be changed, right? It's preventative maintenance. Then we've got the bias cap here. This guy looks pretty old and crusty, so I bet you he's not doing much work anymore. So let's flip this thing around the other way and take a look at controls and wiring. So taking a look at the controls lineup, it looks like all the jacks are original, and they actually used shielded cable going to those. That's very cool because I routinely do that as upgrades. You can see our ground runners going to that brass plate. It's critical to check all these grounds because with a road vibration they crack, right? Other than that, the wiring and everything to the front controls look great. And you can see over here there's our first negative bias cap, and that's been changed too. And it's got the little balancing resistoroids here, the 100 ohmers for the 6-volt filament. So everything's in place. Power transformer looks okay. I don't see a bunch of leakage. Okay, so here is the initial noise floor test. You've seen me do this several times on other videos. It's the first thing I do on these amps, and then I apply a signal and take a look at the sine wave, and that'll tell me a lot about what I'm dealing with. Okay, so I've got my scope hooked to this little dummy load resistor to simulate a speaker. My scope is set at 50 millivolts per division so that it can be nice and sensitive and we can see noise. And you can see the sine wave is bounced around a little bit. right? But that's not a big deal. That's pretty good, to tell you the truth. All right, so first thing I'm gonna do is take my little tweakity-doo-dah. I'm just gonna tap the tubes, okay? Now look at there. Here's the first preamp tube. See that? So that guy's a little microphonic, I'd say, right? Here's the second tube. Here's the third tube, all right? So there's V3. He's got a little bit going on too. That could also be corroded tube sockets, right? And then here are the output tubes. They look good, right? So we know we got some microphonic tubes more than likely. The next thing I'm going to do is just go down here and tap components on the eyelet board and look for sensitivity. So I'm going to start at the top. So here we go. So I'm hitting those blue caps right now. A little jumping around, that's normal. Okay, that's not a big deal. Now here is that ceramic cap that I usually have issues with. Let's see what it does. Whoa! Look at that guy. Look at there. I'm just kind of bouncing it, right? I'm just kind of going boing, boing, and watch the scope. Boing, boing. It's like a little microphone. That's why those ceramics gotta go, guys, right? No reason to check it. You see what it does. Let's go down the board. So I'm going to keep on tapping. So there's sensitivity all over this thing, especially right there. Look at that guy. Bam, 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 bam. And guess what I'm hitting? It's another ceramic cap. All right, I've seen enough. Let's give the board a little more of a thorough look over for bad connections. Then I'm going to change those caps. So giving her a closer look, you can see some pretty terrible solder connections, like right there, up here, right there. That's really bad news, right? So that is also part of our sensitivity issue. But there's no doubt in my mind that this cap, the old troublemaker, was causing a lot of the lower frequency distortion that we saw in the scope. Okay, so anyway, that's what we're going to do is we'll touch up the board, we'll change the caps. But before I do that, let's run a signal into it and take another look at the scope. Alright, I got the main lights off. We're hooked into the input with the audio generator, which is up there. Set at about 800 Hertz. I've got the scope now at about 2 volts per division. And I'm going to bring up the volume and take a look at the sine wave. It actually looks great. Nice and clean, symmetrical. So I don't really see any issues there. But now, let's say I bring that up and let's tap on that microphonic tube. See there? Doesn't seem to affect it. Take the volume all the way down. You don't see anything. Well, that's because I'm at 2 volts per division. Let's go back down to the 50 millivolt. There it is. Bing, 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 bing. So you would have that as background noise when you're trying to play your amp. Well, that wraps up the initial evaluation. I'm going to get in there and change those caps. Now, I'm not going to show the installation of the master volume in this video. I already covered that step by step in a previous video. This one is just to show you some more noise issues on the Fender Bassman. So as a precaution, before you go in there and start changing caps, get your meter out and check the voltages on those power supplies. Make sure they're absolutely dead. Or when you take that nice grounded soldering iron and put it in there, guess what? Boom! Since I identified these .01 ceramics as my main violators, we'll just start with those. So I've got some nice Sprague orange drops that'll go in their place. These are the 715 series 600 volters. Pop them in, and then I'll start maybe in the grid caps, and we'll work our way across and change out the blue uglies. I'm using my new Heiko, the old 951. Get the old tip nice and clean. We'll start popping out those caps. Get your wiring out of the way, obviously, because you don't want to melt that. But you can pretty much heat that eyelet, and if it doesn't want to heat up right away, add a little bit of solder to conduct the heat off that tip. Keep the wiring out of the way. See, once again, I have to add a little bit of solder. Be patient. Boom, she's out. Once again, what I love about working on eyelet boards is you get to change all the parts from the top. It's not like on these new circuit board amps where you got to keep flipping things and it's just a big mess. So you wonder, why do guys like to work on tube amps? So installation of the cap is just the reverse of pulling her out, right? Get on the eyelet, heat it up, get your cap ready. Make sure your leads aren't too long, because you want the new cap to sit down on the board. So obviously my lead's still a little bit too long, right? I probably should have measured that. So let's trim that up and try it again. I don't like the caps to be way up off the board like this, because it'll just dangle around. There. So that's about where I'm going to want him. I'm going to turn it, cut this lead, and get it into that eyelet. There, here we go. Got the lead ready. Heat him up. Get him down the eyelet. There you go. You don't have to be paranoid that you push the lead down too far, because under this board is another board which is an insulator. So the leads will just hit that insulator board and not hit the chassis. But I would advise that you make sure that that insulator board is there. So even though this little green cap here is a replacement, I really don't like it. I don't know who makes it, but it just looks cheap. Alright, so I'm going to get that out, because when we're done here, once again, got to transfer some heat. Once we're done here, I want to see all orange, right? I don't want to see ugly blues, and I don't want to see this little green guy here. And look at there. So out with the old, in with the new. We're all orange now. Time for a retest. Retest time. Got the new caps in the amp. Scope is hooked back up to the dummy load. We're at 50 millivolts per division, just like we were on the initial test. So we'll kill the lights. Boom. How do you like that? Now I'll take the magic wand. We'll do the tap test. So let me zoom in on the scope so you can see the trace. Here we are. Here we go. Now remember, the disc cap was right here. Remember, I'd like hit that guy and you'd see the sine wave? Gone. There's still some sensitivity, but remember, we had that microphonic tube, which was V1. So that needs to be changed still, alright? I have not gotten to the tubes yet. So right now, we've changed all the caps. Next, let's swap out the preamp tubes and see if we can kill that. V1 has been changed. Now this was some old Marshall identified ECC83. I replaced it with a Savtec 12AX7 LPS, which is D-Lab's go-to preamp tubes. So here's a Scoporamus bashing on the tube. Quiet as can be. So the initial noise problems with the Fender Bassman are fixed. Next thing I need to do, obviously, is put in the master volume control, which this video is not about. This video is to show you some quick ways to solve noise issues with the Fender Bassman. You can see the caps are a major contributor. Bad solder connections, microphonic tubes. So there you go, another tech tip from D-Lab. We'll see you.